Hey guys. All right. In this lecture, we're going to be looking at life history. And so what we're going to do is take a 15, 20, or maybe a little longer run through life history on the planet, starting with this is basically of when the planet formed up to the modern era today. So of course, we're only going to use the highlights. Let's just call it that. If we were to do it all, that would be a course of its own. So let's go ahead and get started here. So the timeline of Earth's life history is broken into several major divisions that we'll see here. I've got a couple of key points that are outlined on this here. We have the origin of life occurring in the Archean, about a little bit between 3.5 to 4 billion years ago. Then the first eukaryotic cell, so the first cell, occurs in the Proterozoic, let's just say around just a little bit before or just a little bit after 2 billion years. And then multicellularity, so multicellular organisms like ourselves that have more than one cell, don't occur not too long ago, about 500, just a little bit more than, so 600 million years ago or so, compared to of how long the planet's been alive for about 4.6 billion years now. So let's go ahead and kind of run through this, and I'll take you through Earth's life history here. A nice good crash course through it. So starting off in the Hadean, what we are dealing with is, and just so you know, the top bar here, if you were to grab, for instance, some kind of like a meter stick or a fabric measuring tape, and then you put it onto the centimeter side, if you want to, you can do this by adding pieces of tape at these markings that will then correspond with when that is occurring. So that way you can see this in front of you to get an idea of how long that time frame is between each one. Because sometimes it's a little difficult to really understand how much is 500 million years, right? It's like, someone is telling someone, oh, I've got, $100 in my pocket. But really, how much is that worth if you're not used to dollars and you're used to maybe euros or some kind of other currency? All right. So the Hadean era, or sorry, the Hadean eon, okay? Because it's one of our biggest divisions. 4.6 billion to 4 billion years ago. Of course, the Earth is getting older every single second. But what was happening here for about a little bit more than 500 million years? Well, the planet was just a dust cloud, and that's what you're kind of seeing in this representation here on the top right. And as that started to coalesce because of the gravitational forces pulling it in further and further as the universe and various different planets were beginning to form, what we're seeing is that as this massive amount of dust starts to coalesce together for the planet Earth, it just becomes a searing wasteland, sort of like this representation here on the bottom right. Really hot, just molten rock all over the place. Nothing really can survive that type of surface temperature, but at that point, we also didn't really have an atmosphere at all. So we don't have any fossils of this. The only thing that we have is maybe some organic compounds that are preserved from this time frame, but we don't really have much. So that ends with the idea of the Earth's crust beginning to start to cool. So that lets off a little bit of a difference, right? Makes the surface of the planet perhaps habitable to some very primordial and basic organisms. And so the first sort of organisms and known life on the planet, on Earth, are what we call stromatolites. The stromatolites that we're seeing on the bottom right look like these mounds of rocks. And so it's not really a cellular organism, it's just kind of organic compounds that seem to be utilizing various different molecules to provide themselves some energy to just live and live off of that. But they're very much just sessile beings here. I don't even want to necessarily call them an organism, if anything. And this image here on the top right is that of a cross-cutter, so like a stratigraphic column that we've taken like a ham slice. And so we can see these little mounds like these popping up as these stromatolites. So what occurs here? Well, we're dealing with about a 1.5 billion years worth of time if you're following along with the ruler bar here up at the top right. But what's occurring here is that the atmosphere was, for the most part, CO2. So that's, if you're familiar with the different types of terms that are used in common media today, that's going to be one of the primary greenhouse gases. So yes, the temperatures of the planet were quite a bit warm, particularly on the surface. But what this means is that we were perhaps starting to form an atmosphere. So then, zipping over on into the Proterozoic eon, we are dealing with, again, about another 2 billion years worth of time that it covers. Proterozoic is defined as before visible life. So we have a pretty good idea now that there was definitely life during the Proterozoic, but it wasn't really what we expected today. So three things were occurring here. The first one is that we had photosynthetic bacteria starting to spew out oxygen. And that eventually leads into plants and other things. So we, as humans or in other different animals on our planet, we have evolved hand in hand with plants. And so what we end up having is this kind of symbiotic relationship where we breathe out carbon dioxide and plants breathe in that carbon dioxide. That's their oxygen. But what do they breathe out? What we breathe in, oxygen. So we have evolved on this planet together with each other. And if one of us goes extinct, the other goes extinct as well too. So what that then leads to is the formation of eukaryotes. So the idea of a single-celled organism having a nucleus, various different organelles of what we're seeing here. Each of these organelles have particular jobs that they do. And if you take a cell biology course of some sort, a basic biology course beyond this, then that's going to be one of the things that they talk about there. But this then leads into more of the possibility of a soft-bodied organism beginning to evolve. And so that's what we start to see. The fossils of these are really rare because they're soft-bodied. Anything that's soft and squishy decays away over time. So to be able to preserve those, usually we only end up having like impressions of them in rock. And you may have seen that of like an impression of a leaf fossil or something like that along the time of you that you've seen maybe on TV or in a book somewhere at one point. So then we finally get into what's called the Phanerozoic eon. And this is where we are currently now. So this is the eon that we are living in. This has lasted for about 500 million years, and it's counting and increasing every second. And it translates to visible life. So like what we are seeing here on the right picture, this is what we're going to dive through these various different eras. And then for the rest of the course, we're going to mostly focus on the Mesozoic because that is the purpose of this course. Dinosaurs, right? That's the coolest part. So we start off with sort of aquatic invertebrate fish-like animals that then make their transition onto land. So we have some really weird looking kind of mammalian sort of organisms, lizardy kind of thingies. Some of them look like typical lizards or iguanas, but a bit different still than what we have now. Then we get into dinosaurs, and then finally into mammals. So we make this progression between Paleozoic, Mesozoic, and the Cenozoic, which is where we are currently in now. So let's dive into the Paleozoic. So this lasts for about 250 million years. So about 250 or so, 300 million years. And this starts off with something called the Cambrian explosion. Now, the one thing I want to make note here is that the term Cambrian explosion is a metaphor. It's not an actual explosion that happened on the planet or some kind of an impact or whatever. We'll get to those in a little bit. But in this case here, it's an explosion that's metaphorically indicating that there was an explosion or an increase, a vast increase in the amount of life that we were seeing on the planet. But the caveat to that is that life still existed prior to that, and probably quite a bit of it, but it was all soft-bodied organisms. So now what we're getting is organisms that have hard parts. So in this image here on the top right, we've got a bunch of weird organisms like this here, Hallucidogenia. It's like this little worm that has kind of spiky, thorny, toothpick-like legs. We've got these organisms here called trilobites that were of various different sizes. We've got acorn worms, a whole slew of different things swimming around. But each of them had something that was a hard part to them. And that is what then would preserve, which would give us an indication of what we have and we can see of the actual animal. One of the primary areas that we see this is in the Burgess Shale, which is located in kind of the most western coast of Canada. So then as we slowly progress, we start to evolve fish-like organisms, but it's not fish that we see today. It's more fish that are armored fish. So they have these kind of weird armored like platings on their backs or on their faces. They all are now extinct. So, but they have some sort of derivation where fish that we have modern day today begin to make their way and continue to evolve around in this same time as well too. But after this, right? But the other thing that's occurring is we've got plants are now making their way onto land. So in the seas is where life started, and there was nothing on land. And part of that is because there really wasn't a good atmosphere. So now once we have plants making their way onto land, then that sets up the possibility of an atmosphere. So there is oxygen out to breathe. And so then animals start to make their way onto land as well too. So then finally, towards the very end of the Paleozoic era, what we end up having is a bit of an an issue here. We have what we call an extinction. But prior to getting to that, I want to say is that around the same time is where we have that supercontinent called Pangaea beginning to form. And what's occurring here is that as if, let's say, this was separated out and this was separated out and this was separated out, as these start to form together, then animals can start crossing over onto different types of land. They perhaps might be able to find a better environment for themselves to live in than they were currently living in, and then therefore they evolve based on that environment. But at the very end of that, we get the Permian extinction. We now know that the Permian extinction was due to an increased amount of volcanic activity that was occurring on the planet. So as that volcanic activity is occurring, it's spewing out various different noxious gases into the atmosphere that's causing acid rain, clouding out perhaps some of the sun, and a lot of other aspects that are kind of occurring to change the ecosystem and the ecology of the world. So if the plants started to die off, then the animals that eat the plants die off, then the animals that eat the plants die off. And so you can kind of see how that spirals downwards. This is the biggest extinction that has ever happened on the face of the planet, where more than 70% of land animals died and almost 96% of marine life died. Nobody was protected in this case. The only thing that kind of helped animals was if they were able to translocate from one area to the next more quickly, or perhaps if they were able to go underground or some kind of protected region. You'd wonder, well, why is it that in the marine world the water wouldn't protect them? Well, if those noxious gases and there's rain that's still coming down, that is going to mix into the water, which will change the chemistry, and it will make the water chemistry a bit more acidic, perhaps, and therefore then that's going to make it a toxic environment for all the aquatic organisms. Even more dangerous than if you were to just able to like dig underground or something. But as a supercontinent forms, the one thing I'm just going to mention here is that our mammalian predecessors begin to evolve somewhere around the equatorial regions. We're going to get back to them a little bit later, though. So then we get into the Mesozoic era. This is, we're going to go through this really quickly here because we're going to spend the rest of the semester on it. But this is nicknamed as the Age of Reptiles, or even more better, the Age of Dinosaurs. So this is broken up into the Triassic, the Jurassic, and the Cretaceous. And we'll again go in through this in quite a bit of detail throughout the semester. Here we have a nice, good depiction of probably the late Cretaceous of the Hell Creek Formation in the Montana, South Dakota, North Dakota region here of the United States, with T-Rex, Triceratops, a variety of other different types of organisms here that lived during that same time too. So a couple things happen here. Towards the end of the Cretaceous, we start getting flowering plants beginning to pop up. So that starts changing up the idea of different types of insects. Flowering plants are going to start to invade. Plants that have, prior to this, we kind of had more of conifers, so pine trees, things like that. And then we start getting more deciduous trees, so maple trees, oak trees, trees that have leaves, right? And those start to really take off afterwards. But one of the things that you're kind of seeing in this depiction here in the very background, if you noticed it, looks like there's some kind of like an extraterrestrial object coming in. There was an asteroid impact. And that's what we refer to as the KPG, or you might have perhaps in the past heard it as a KT extinction. We'll talk about more about this towards the end of the semester as we wind off and we finish off with extinctions. But with this KPG extinction, this is probably the second maybe the third largest extinction that has ever happened on the planet. And what happened is that it wiped out all of the dinosaurs except for birds. So birds are dinosaurs and they lived on. And why? Well, there's really good research beginning to show now that birds, because they ate seeds, and seeds can hold their nutritious value and can stay dormant, kind of asleep for many, many thousands of years, that by eating them, they were able to keep maintain that nutrition, whereas other organisms could not. The other part of this extinction is that what it would do is that this impact, as it hit in the Yucatan Peninsula in Mexico, it spewed up. Obviously, everything within a certain radius of several hundreds of miles was immediately decimated. I mean, it was just like it just poof, vanished, right? There was massive tsunamis, an incredible amount of seismic activity occurring. It's like someone, if we've watched probably a football game at some point and you've seen the quarterback really get like a big sack by a linebacker, and you just like you almost feel the hit. That is sort of what happened here. To the extent where we actually believe that the axis of the planet may have been taken off of what its normal axis was, and then therefore some of the days and everything else was adjusted afterwards. So with the impact, what occurs is that then all of this material, so all the dust then that settles in the atmosphere. That then clouds out the sun, which makes the temperature on the planet a little colder, almost like a nuclear winter. But because there's no sun coming through these thick clouds of dust, then the plants that need the sun to continue photosynthesis can't do that, so they die off. Then the animals that eat the plants die off because not only is there a lot less oxygen to breathe in, but also they don't have any food. And then, of course, the animals that eat those animals die off because they too don't have any food or oxygen to breathe. So animals that were able to, once again, translocate a bit easier. So for instance, something like birds were able to move from one area that perhaps became unhospitable and some other area might have been a little bit better. Animals that were able to burrow, those are usually the ones that were able to survive. And then finally, the Cenozoic. So with that massive extinction, what results here is that now mammals take over. But if you notice on the previous slide, mammals were still around and they're actually predate dinosaurs. But what we end up getting here is, think of it as like let's say you're living on your street and all of a sudden everyone moves out. Everybody on your street. And there is perhaps a neighbor that you've got that has a house that you're like, oh, you know what? I really like that house. I want to kind of go check it out. Maybe I initially, let's just say you're going to be kind of shocked, be like, oh, what's going on here? Did the rapture happen? But then eventually you're going to start thinking like, oh, well, no one's ever coming back here. Might as well see if there's a better house to live in than the one that I'm living in now. I need a little bit more space, perhaps. So you look around, and one of the things that I would, for instance, do, I would definitely move into my neighbor's house in the back. They've got a little bit of a bigger house than we do, a nicer yard. They've got a garage I don't. So I'd love to be able to move into their house compared to mine. Well, that's what these mammals do. So we get this huge diversification of these experimental type of forms of mammals that I like to call mammals 1.0. So we start getting rhinoceri that are about the size and bigger than elephants here. We start getting pigs that are what we nickname as hell pigs, Daedon, that would basically eat you alive in like a couple bites that you can see on the bottom left here. We get massive, massive apes that, again, much larger than what we have. Crocodiles are way, way larger. Crocodile isn't a mammal, but still there's some diversification. Kangaroos that I wouldn't want to come across one of those. Armadillos the size of a Volkswagen Bug, and so on. So we get all these various different animals that have these really weird forms to them, but they are mammals. And that changes, though, a little bit. So when we get into around 34 million years ago, the climate, again, starts to change quite a bit. The ice caps start to take in a little bit more of the Earth's water because the planet starts to cool down a bit. But what that leads to is that by sucking up a bit more of that water from the lowland areas of the continents, that then allows for the formation of grasslands. These wide spreading, vast open areas of land. So if an animal needs to, let's say, get from this forested area here, if you're looking at the bottom right image from where my cursor is, in this forested area, and let's say that there's another forested area right in front of us where this picture is taken from, they have to cross almost like no man's land, where they can be very easily predated upon by another animal or another predator. So to be able to get across that, the thing that you need is to be able to run fast. So this is where we get mammals 2.0 starting to pop up. The fast runners like horses, antelopes, cats, dogs, the various different types of big cats that we're seeing on the planet, like cheetahs and things like that. These animals that run fast now because they have to be able to move from one location to the next. So continuing along that then, as we get into the 2.6 million years ago, those ice caps expand even further, covering up pretty much what we had here in Pennsylvania, where I'm currently now. And that sets the stage for what we call the Ice Age. So these animals that we had before of the mammals 2.0, they start to pick on the pounds, perhaps get a little bit larger in body size, get lots more hair so that way they can stay a bit warmer. So mammals explore that aspect of extreme body sizes in the same way that actually dinosaurs did 100 some odd million years prior to them. But then finally, 15,000 years ago, the climate begins to warm up, and that leads to this next mass extinction. And this is the last mass extinction that we've kind of had most recently, where effectively those ice sheets start to come back. So they start to recede and they scrape away all of that land that was above it. So what the reason why we, for instance, in Pennsylvania, there's a couple spots of the Cretaceous and Jurassic outcrops, but I can't really go out digging for dinosaurs in Pennsylvania because all of that rock, which is on, so Cretaceous happened after, so more recently than something like the Paleozoic, all of that rock was scraped away by the glaciers as they receded. So all we're left over is with a lot of Paleozoic strata in Pennsylvania. So all these different shales and everything else that you're seeing, that's the Paleozoic. So to finally, let's kind of summarize this. So what we end up having here on this slide is a nice summarization of the Phanerozoic. So what we've got is the Paleozoic, the Mesozoic, and the Cenozoic. They're the kind of visible life time frame that we are going to spend most of our semester talking about. And although we'll focus on in this area here, the Mesozoic, I'll kind of talk a little bit about the Cenozoic and the Paleozoic here and there because it's kind of important to understand some major transitional things. But what we can see here is lots of fish, right? Some fish go extinct, like those armored fish. Some fish live on, continue to live on to the modern day fish that we have now. So all your goldfish and everything else, they actually are some of the last fish to have evolved right over here. Then after the Permian extinction, we start getting a bit more of a diversification of different types of organisms that are on the planets that are more tetrapods. So therefore, they are walking around on land. Amphibians, reptiles really get their burst. So this is where we get that. And birds start to make their way up. But as you can see, mammals definitely are still going. Now, this is a little bit outdated from this figure, but I like kind of what it shows. But mammals should actually extend down to about here, so where my cursor is. So they actually predate dinosaurs. And then finally, in the Cenozoic, which is our modern day now, we still have some fish that are alive. So for instance, sharks. We have a couple other things like chimeras that are around. We have the, koi fish and guppies and goldfish and things. We still have some reptiles and lizards, some amphibians. But then birds really burst onto the scene, and that's when mammals also get their burst onto the scene as well, too. So finally, the one thing that I want you to be able to get from this lecture is to understand just the general sense of how life history occurred, the transition of different types of animals, kind of starting off with fish, evolving into different type of amphibians and reptiles and other things. But those animals still existed. So the previous ones, like fish, they still continue to evolve. So it's not like we're building a ladder like we talked about in the previous lectures about phylogenetics and evolution. So in this case here, in this slide, what I'm depicting is that we're taking all of geologic time of the planet Earth, so the 4.6 billion years, and putting it on a single calendar year from January 1st to December 31st. So what we end up seeing here is that things like the Hadean lasted about 2 months and a week or so. Then the Archean, another 3 months or so. And then once we get down to the actual aspect of visible life, where the Cambrian explosion occurred, that was around November 18th. Okay, just a little bit before Thanksgiving. If we look at dinosaurs, people say like, oh, dinosaurs occurred so long ago. Well, I suppose based on human years, but on geologic years, it really wasn't that very long ago. Okay. If we look at December, dinosaurs started up, if we kind of talk about, let's say, the Jurassic or so, they started up around December 15th and really made their rise then. And then they died off right around Christmas. So that was their Christmas present, unfortunately. They got coal instead of a nice, good present under the tree. And then mammals take off after that. If we consider and add in some human dates into this, the idea of Rome, so the fall and rise of Rome happened within the matter of 5 seconds just before the stroke of midnight. So 5 seconds ago, if we're dealing with the stroke of midnight, is when Rome rose and fell. And that's a lot of time for us, right? That's several thousand years, or several hundred years or so. And we can't really always comprehend that idea. So throughout the semester, when I'm talking about, oh, this many million years, take it back to this idea here of a calendar year. So that way it gives you a representation of, oh, you know what? That actually isn't that long of time ago. All right, so to finish off, this was our geologic time scale. Once again, we read this from the bottom right where we had the Hadean. So we went through all this where kind of the planet wasn't very habitable. We started getting some basic life here. Obviously, towards the end, we started getting some of those softer bodied organisms from things like the Edicarian and such. And then boom, the Cambrian explosion. We started getting fishy-like organisms, salamanders and frogs and things, and other amphibians, moving into predecessors of reptiles and mammals. Then the age of reptiles and dinosaurs, and then finally the age of mammals in the Cenozoic. So with that ends this lecture here. The next one is going to be on the general anatomy of our body, where we'll discuss a little bit about bones, some various different definitions, so that way we can understand when I mention a certain bone for the rest of the semester, what does that relate to?